All right, here we are graphing hyperbolas using vocabulary. I'll do two of them with you to make sure you know what's up. This first one says graph a vertical hyperbola. So vertical hyperbolas kind of look like this. And so we know the vertices will be above each other. We also know the transverse axis will be vertical. And we know the conjugate axis will be horizontal. So we know all of that just from seeing vertical hyperbola. Okay. Graph a vertical hyperbola centered at 0, 0. So we're going to put the center there, with a transverse length of 4. So again, this is where we had to use the fact that it was a vertical hyperbola. So the transverse axis is up and down vertically, and it has a length of 4. So it must be 2 up and 2 down. The end of the transverse axis are the vertices. So these are the vertices. The conjugate axis length is 3. So remember, both of them are centered at 0, 0. It must be 1.5 over and 1.5 over in the other direction. This is the conjugate axis length. And now we're going to create something called, we're going to call it an X box. And we're going to use it to graph the asymptotes. What we're going to do, this is not part of the hyperbola. This is what we're going to use to make the X box. And we're going to make a perpendicular line to both the conjugate axis and the conjugate axis and the transverse axis. And where those lines intersect, that's going to be the corners of our X box. And the reason we're calling it an X box is because this is where the asymptotes are going to go. Excuse me, I had to grab a red pen because I want to do my asymptotes in red. So the asymptotes are going to go through the corners of the X box and also through the center. And again, remember this was a vertical hyperbola, and so these are the vertices. You get closer and closer and closer to these asymptotes. You kind of curve out, and they get closer and closer and closer. And so in the middle, this graph is kind of curved. Like there's this curved part. This is the hyperbola, these two sections right here. In the middle, if you kind of like take this part away, you've got kind of parabola-looking things. But if you get rid of that middle section, what you actually have is kind of straight lines. These are following the asymptotes. They're very close to straight, and it almost looks like two linear functions that would intersect, and they would intersect at the center. However, they curve up and meet each other instead. All right, let's do one more and make sure we can graph this using vocabulary. Graph a hyperbola with vertices at 2, 4 and 2, negative 2. Okay, so again, it's telling me where the vertices are. So it's 2, 4 and 2, negative 2. Since the vertices are vertically placed, I know this must be a vertical hyperbola. The transverse axis is going to be connecting the two vertices, and I know that the center will be halfway in between the vertices. So it'll be right here. This is the center. But even if we didn't know that, it tells us right here the conjugate axis is y equals 1, which is a horizontal line, but it's only defined on the interval from negative 1 to 5. So that conjugate axis only goes from negative 1 to 5. They also could have told us, equivalently, they could have told us that the conjugate axis has a length of 6, and we would have been able to figure it out from that. Again, once we know the conjugate axis and the transverse axis, we're going to make our X box. So we put a point where the perpendicular line would intersect the endpoints of the transverse and the conjugate axis, and this is the line where the X box goes through. Okay. And the vertices were at 2, 4 and 2, negative 2. So this is a vertical hyperbola. This one's a little bit more wide than the other one. If they had told us that these were the ends of the conjugate axis, then the vertices would be here, and it would be a horizontal hyperbola, but it was not. Okay, a couple extra things that we should know. Let's see. The equations of the asymptotes. They're linear functions, and so there are two things we can use. We can use y equals mx plus b to write the equations of the asymptotes. The slope can be found by using the center and one of the other points, or one of the endpoints. So if I use this point and this point, the rise over the run, so it's change in y divided by change in x, or y2 minus y1 divided by x2 minus x1, it goes up by 2 over by 1.5. So the slope is 2 divided by 1.5. To rationalize this, or to make it whole numbers, we would multiply by 2 and multiply by 2. This is 4/3. So the slope is 4/3. The y-intercept here is 0, and so the equations of these asymptotes are 4/3 x, and this one has the opposite slope, so negative 4/3 x. Sometimes if the center is translated, we might want to use the transformation form of a line to write the equation. It's a little bit easier. So again, the slope is up by 3 over by 3. So the slope is 3 over 3, which is 1. Okay. And, you know, that's right. Okay, cool. Here we can see the y-intercept is 1 and the y-intercept is 3. So we get y equals x minus 1 and y equals x plus 3. But sometimes it's useful, well, I didn't do a great example for doing the transformation form, but that's okay. We'll stop there. There are a couple other points of this parabola we'll get to, or these hyperbolas, which we'll get to in the next video based on the equation.